Hello everyone and welcome to this session on asynchronous programming. Imagine you are at a restaurant. You place your order and instead of waiting at the counter for your food, you go find a seat. While you are relaxing, the kitchen is busy preparing your meal. Once it is ready, they call you to pick it up. In the meantime, other customers are being served, and no one is stuck waiting for just one order to finish. This is exactly how asynchronous programming works. In programming, tasks often take time, like fetching data from the internet, reading files, or interacting with a database. If we handle these tasks synchronously, the entire program will stand still until each task was finished. But with asynchronous programming, your program can keep working on other tasks while waiting for those time-consuming operations to complete. When they are done, the program notifies you and continues where it left off. So why learning asynchronous programming? One is improves efficiency. This means your programs can handle multiple tasks at once. Also user-friendly, which means you're going to make your app run faster and more responsive. And also core in JavaScript. This means JavaScript was built with asynchronous programming in mind, and you will use it for almost everything from web development to APIs. What you will learn in this session. One is understanding synchronous code, and also how JavaScript handles asynchronous tasks, the key tools for async programming, and that is callbacks, promises, and async await. And working with APIs, and that is HTTP requests, we will build a couple of real-world projects to reinforce our knowledge. So get ready to unlock the power of multitasking in your code. By the end of this session, you will be writing programs that are not just efficient, but also feel magical in how they handle multiple things at once. Let's dive in. Let's get started with asynchronous programming. Understanding this concept as a backend or front-end or full-stack developer is very important, so I advise you to take some notes as we move on. By the end of this section, we are going to build interesting and amazing projects by using other APIs, which means that we can build AI-powered applications. So let's get started. Before we get into asynchronous programming, understand that we have two main types of programming paradigms, and that is asynchronous programming and synchronous programming. Sometimes we refer asynchronous programming as asynchronous code and synchronous programming as synchronous code. We often use them interchangeably, but they serve different purposes. At this point, understand that asynchronous programming is the same as asynchronous code, and synchronous programming is the same as synchronous code. At the end, I will give you the differences. So to better understand asynchronous programming, first, unless we know what is synchronous programming or synchronous code. And this one deals with how JavaScript executes code. In synchronous programming or code, JavaScript executes code line by line in the order it is written. This means that JavaScript reads your code from top to bottom the way it has been ordered. This means that each line of code waits for the previous ones to complete before running. This means only one operation is processed at a time and no other task can start until the current one finishes. At this point, I believe you've seen the challenges when using synchronous programming. Let's use this diagram to explain more before we get into the drawbacks when using synchronous programming or synchronous code. In this diagram, as you can see, we have many customers to be served. And let's say this customer would take 2 minutes to be served. This means that unless this customer is being served before moving on to the next one, And let's also assume that this customer will take 20 minutes to be served, which means that this customer needs to wait until this customer is being served. At this point, I believe you've seen the challenges when using synchronous code. One is blocking behavior, and that is if a task takes a long time, it freezes the entire application. And also reduce responsiveness. This means that applications relying on synchronous code may become unresponsive during heavy operations. For instance, in a browser, the user interface may freeze while waiting for synchronous tasks to complete. Apart from that, we also have inefficient resource utilization. In synchronous code, the CPU or other system resources may sit idle while waiting for tasks like I/O operations to complete. This underutilization reduces the efficiency of modern system design for multitasking. Also, scaling issues. Synchronous programming often faces challenges when handling multiple simultaneous operations. For example, a synchronous web browser can only process one request at a time, leading to bottlenecks. The next point is it is not suitable for real-time applications. Real-time apps like messaging systems or live updates require tasks to run concurrently, of which synchronous code cannot handle them effectively. And lastly, complexity in long operations. If you have multiple dependent tasks, writing synchronous code for them can become cumbersome and inefficient. At this point, all the codes that we have written are synchronous code or programming. This is where asynchronous programming comes in. We are going to have some code examples to explore synchronous programming. Back to Visual Studio Code. I have created a folder called Asynchronous Programming, and I have my index.html file with the heading called Async versus Synchronous Programming, and I have linked up my JavaScript, and this is a preview. So let's get started with synchronous programming. Like I said, until this point, all the codes that we have written, we are utilizing the synchronous programming or synchronous code. Before we continue, synchronous code is sometimes referred to as blocking code. And then async code or programming is sometimes referred to as non-blocking code, meaning that a code that blocks other codes from running, but for async it doesn't. So let's begin with synchronous code or programming. I'm going to write some code. Let's just use console.log. Remember that console.log is a function. So I'm going to have console.log, and I'm going to say that step 1 is start boiling water. So these are our tasks that we want to perform. Then step number 2 is add pasta to the pot. And step number 3 is stir and wait for 10 minutes. And lastly, step number 4 is drain the pasta and serve. This code is going to run the way it has been ordered, which means that first come, first serve. And that is, it will run from top to bottom. In the console, this is how it looks like. Step 1 first, followed by step 2, 3, and then 4. Let me change this one to step 4. At this point, I believe you understand that in the synchronous environment, codes are executed line by line depending on how it has been ordered. If I bring step number 4 up here, step number 4 will be executed before the step 1, 2, and 3, and that is how it has been ordered. For these codes, we don't have any issue about it, simply because it doesn't take much time for each of these codes to be executed. This means this is simple code without performing any side effect, and that is making requests or taking some time to be executed. Let's have one more example. For this example, the function or the execution of the code will take some time. So I'm going to have a function as blocking task. And in this function, we can perform some HTTP requests or talking to other server or consuming other APIs or reading from a file or reading from a database. At this point, we are just going to simulate some delay. So in the function here, I'm going to have one console log by saying that step number 1 by saying that starts a long running task. Then below here, I'm going to simulate a blocking task by using while loop. So I'm going to have a variable as const start time is equal to date dot now. Then in the while loop, I'm going to take the date, and that is the current date, then subtract the start time. If it is less than 5,000, then in here, we are going to execute some code. In here, the loop will run for 5 seconds and blocks the event loop. And we will talk about the event loop. This means that this function will take some time before executing. Then below here, I'm going to say that console.log step 2 long running task finished. When you call this function, let's see the execution. I'm going to call it as blocking task. So in the code, and this is how it's going to be executed. First of all, it is going to run the console. First of all, this one will log. Then from there, it will get into the while loop. So this is where it's going to take some time to finish the operation. This means that this code will not run until this one finishes. So with this one, let me comment out the previous ones. And if I save it, now let's see, as you can see here that we got start a long running task, and then we got the long running task finished. And from there, we saw the text on the page. If I reload, it is going to rerun the function. So let's see the effect now. As you can see, it is loading here by taking some time, and this text is gone. And finally, we got the result before we can see the text on the page. At this point, we can say that our application is not responsive because it keeps waiting here, and then the content is lost until the operation finishes before we saw the content. At this point, I believe you've seen the effect when it comes to synchronous programming. And we can even console log something here by saying that before calling the blocking task. And then also here as after the blocking task. So let's see the execution of this code. In here, this one will run, and that is line number 15, before calling the function. Then in the function, it is going to execute the console.log, and then when it gets to the while loop here, it's going to take some time before executing this. And lastly, it will call the last one here. With this one, if I save it, as you can see, everything is blank, and we got before calling step 1, step 2, and then after the blocking task, and we got the result on the page. And that is our content. And this one imposes some challenges as we spoke about. This is where asynchronous programming comes in. Now that we've talked about synchronous programming, let's focus on asynchronous programming or async code. It is opposite to synchronous programming. This means that this allows tasks to run in the background without blocking the execution of subsequent code. It uses mechanisms like callbacks, promises, or async await to handle tasks that take time, such as fetching data or reading a file. Unlike asynchronous code, async tasks don't wait for previous tasks to finish. Instead, they are handled concurrently, and notification mechanisms like callback or promises triggers the next step when the task completes. As you can see for this one, it is going to improve the performance of application without blocking other codes. As you can see in the picture, tasks run independently and no blocking is required. Let's use this one as an example. In here, we have many chefs ready to serve customers. This means that customers can be served randomly without waiting for other customers to be served. This is all what async programming works. So let's get back to Visual Studio Code to explore more. I'm going to comment out these codes for the synchronous, and let me have a comment as async code. And we're going to use a simple code to demonstrate by using setTimeout. Up here, I'm going to console log something like task 1. And then below here, I'm going to have task 3. Now, in between, I'm going to simulate some delay by using what is called setTimeout. So in here, we're going to pass in callback function as that. And the second argument is going to be the time that we want to execute the code in the setTimeout. In here, I'm going to log by saying that task 2, and this is going to delay. When I save this one in Synchronous World, it is going to execute this one. When it gets here, it's going to delay until this one finishes before calling this one. But in async code or programming, let's see the effect. As you can see, we got the task 1 and then task 3, and as soon as the task 2 finishes, we got it without blocking the task 3. And if I reload, as you can see the page, we still have the content while the other operations are working in the background. This is what we call async code or asynchronous programming. Now, how does it work? This is where the concept of event loops comes in. Understanding how async code works will help you to master asynchronous programming. In the next video, I will explain how this code works by using what is called event loop. As we move on, we are going to interact with API. That's going to take some time without using the setTimeout. With this one being said, let's continue in the next video. How does asynchronous code works or executed? It uses a concept called event loop. So what is an event loop? In JavaScript, it is a mechanism that allows asynchronous operations to execute non-blocking code. It works with the call stack and task queue to manage the order in which code is executed. Here is how it works. Let's begin with the call stack. Understand that JavaScript executes functions in a single-threaded way, meaning it processes one function at a time in the call stack. Let's take our previous code as an example. This means that we're going to have these functions in the call stack, but it is going to be processed one at a time. This means the first function is going to be executed. So at this point, we know that the call stack is where the functions are going to be executed. Then in the task queue, this is when an asynchronous task, like an API call or setTimeout finishes, then it goes to the task queue. So in this function here, in case we have some async code, in this case the setTimeout, then that function will move into the task queue without blocking other codes to run. So at this point, the other codes assume that we don't have this function called setTimeout. Then in the event loop, it is going to constantly check if the call stack is empty. When it is, the event loop moves task from the task queue to the call stack for execution. Let's try to go over again. Here is where we have our functions to be executed, and this is where the functions are being executed. So in the call stack, we have a couple of codes or functions. In case it encounters a function that uses async code, in this case setTimeout, then it moves to the task queue. Then that function is being moved to the task queue. while other codes are being executed without this code being blocked. So in the task queue here, as soon as it finishes, the event loops keep checking in the task queue. If that function is being finished, then the event loop will move that function to the call stack to be executed. So in this case, the event loop here keep checking. In case the call stack is empty and we have some functions in the task queue, then it moves to the call stack and the call stack is going to execute that function. That is the reason why a function that takes some time to be executed are not being blocked by other codes. And this is what we call asynchronous programming. That is why we see the code being running independently without waiting for other codes. So in this case, the task 2 is being moved to the task queue. Then the event loops keeps checking. In case the call stack is empty, then it calls the function in the task queue to be executed. Understanding asynchronous programming will help you to better understand how your code runs or executed and how to write efficient code for performance. Not just that, it will also help you to work with APIs, and that is Application Programming Interface. Don't worry, we will dive in more about APIs. The main goal here is understand asynchronous programming and how we can use to interact with public APIs. By the end of this section, we are going to work with APIs. If you go to rapidapi.com, this is a marketplace where we can access millions of APIs. This means that we can build an application on top of these APIs. For example, we can build an app on top of this sports API or artificial intelligence. Recently, I have built an application on top of this API to check if a content was generated using AI. And all these are possible because of my understanding of asynchronous programming and how to work with APIs. So knowing asynchronous programming is very, very important. By the end of this section, you can come here and build an application on top of these APIs. And before you can build an application on top of these APIs, you need to understand the following. One is asynchronous programming, of which we are going to dive in more. And secondly, HTTP request and then APIs. Let's begin with HTTP request. This is a message sent by a client, for example, a browser or app, to a server to ask for a specific resources or perform actions. And it uses what is called HTTP request method, and that is Hypertext Transfer Protocol. This is a foundation of communication on the web. Don't worry, when we get to code, you better understand it. At this point, understand that HTTP request is a message that we send to a server to retrieve some information. Looking at the public APIs or these APIs, let's say that I want to build an application on top of Google Translate API where a user can translate either from English to French or French to English. This means that unless I make a request to this API to retrieve the information into my application, and it uses what is called HTTP methods. We have get, post, delete, and update. Let's say that you want some information from a server, and that is get method. And you want to create some document and save it on the server. This is called post method. And if you want to delete something from the server, you're going to use delete method. And for updates, we have what is called put method. If we get to backend, we are going to dive in more about all of these HTTP methods. But on the front end, we're going to use the get method most. So now we know what is HTTP request. The next requirement is understand asynchronous programming, of which we have some fair idea. Now, the next step is how can we use asynchronous programming or concept to make HTTP requests. This is where callbacks, promises, and async await comes in. In the next video, we will talk about APIs. What is it and how we can use it. And from there, we will get into asynchronous programming by using callbacks. As a front-end or back-end or full-stack developer, you are going to work with APIs. So in this video, let's have a brief overview when it comes to APIs, because we are going to use the concept of asynchronous programming to work with APIs. In a nutshell, what is an API? It is a set of rules and tools that allows different software applications to communicate with each other. It acts as a bridge, enabling one system to access and use functionality or data from another system without knowing its internal workings. I think at this point you may be confused. Let's take this restaurant to explain. We have these entities, and that is the client, the waitress, and then the chef over here. Now the client here is our application, and then the waitress here is the API, and then the chef here is the server. In the server, we have the resources that we want to retrieve into our application. So the rules or the process of retrieving the data from this server into the application is called the API, meaning that it is possible because of the API, which means that the API is the intermediate between the application and then the server. In this case, the front-end application and then the back-end application. So assuming that we are using the public API from Rapid API, in this case, this one. Now, let's say we are working with the Google Translate API. This is a server. And then we have our front-end app where we want to retrieve or work with this API. So the process of retrieving the data from the server into application, and this is possible because of what is called API. Understand that the API is the rules and tools that allows different software applications to communicate with each other. And like I said, as we move on, we are going to build our own APIs. At the moment, we're going to use some public API to work with to build awesome application. In short, API are the rules that allows one application to interact with a different one, to retrieve some data or to post some data into that server. With this one being said, we are going to get started how to use asynchronous concept to work with APIs by using HTTP request methods. Let's get into it in the next video. Let's get started with asynchronous code, and that is how we can write async code. And one method is by using what is called callback function. What is a callback function? In JavaScript, it is a function that is passed as an argument to another function and is executed after some operation is completed. It allows you to control the flow of your code and is commonly used in asynchronous programming or to customize behavior. At this point, understand that we use callback in asynchronous code to help us to improve the performance of our code. So in short, what is a callback function? As I spoke about, it is a function that is being passed as an argument to another function. And when that operation is completed, then that callback function is going to be executed. If this one looks confusing, let's use this diagram to understand what is a callback function. Let's take it that this guy over here wants to visit his or her friend in a different home or house. When this guy went, he didn't meet the person at home, but instead he met the mom. So he said that, "Hey mom, I want to go back, but in case my friend comes, then call me back on my number." This means that This is the operation that's going to be performed after the friend comes back home. This is what we call a callback function. Once again, let's use this diagram as an example. Let's say that this customer over here went to a shop to buy some drinks. But as soon as this person went to the shop, the drink that she is looking for is not available yet. But the shopkeeper said that, you don't worry, after some few minutes, we're gonna have new stock. Then the customer said that, okay, then take my phone number. When the goods arrive, then you call me back on that number. This means that as soon as the operation finishes, and that is when the goods arrive, then the shopkeeper calls back the person using the number. This is what we call a callback function. Let's relate this one to a code. Let's say that this is our front-end application and this is the server or some public API that we want to fetch some data into our front-end application. So upon fetching, it can take some time because it deals with some network. Let's say that the request will take, for example, 2 minutes before we can get the data. So while the front-end application is waiting for the data to be fetched, other codes in the front end will keep running. As soon as the data is being fetched, then the callback will take that data and place it in our front-end application for processing. This is what we call a callback function. We are going to have some code example to explain more about callbacks, how to use it, when to use it, and the importance of using callbacks. Let's answer to the first one, and that is importance of using callbacks. One is, it is going to help us to implement asynchronous code. And this is where we left in the previous video by writing asynchronous code by using setTimeout. As you can see for the setTimeout, it is using a callback function. In this case, this one, and that is the setTimeout takes in 2 arguments. One is a callback function and then the duration. As we spoke about, a callback function is a function that can be passed as an argument to a different function. In this case, this one. For this case, the callback is going to be executed after this delay. Now, let's have this scenario when using callback function. Let's assume that we are going to build a weather application. And to build this project, one, we may need an API where we can retrieve that data. And secondly, our front-end application. At this point, for the API, we are going to mimic. As we move on, we'll be using REST API. Let's look at the flow for this application. Step number 1 is that our application will make a request to this API, and the response coming back from the API can be delayed. Let's say that it can delay for 40 seconds. And this one can happen based on the user network. And the second step is that after we got the data from the API, then we are going to update our application UI to display the temperature and other properties. In this case, our application is going to depend on the response coming back from the API. So as soon as we get the data, then our front end is going to operate on the data to display the data into the application. But here is a catch. While it is fetching, other operations in the front end will continue. So as soon as the data comes back, we are going to give that response to what is called a callback function. And that callback function is going to notify the front end that, hey front end, the response is being back. Therefore, operate on that. The main purpose of the callback function here is that it is going to wait as soon as the response comes back. Then the callback function is going to notify the front end that, hey front end, you got the data, therefore you can display to the page. That's all what we are going to do. Like I said that, we are going to mimic. As we move on, we're going to use REST data. So first step is that we are going to have a function to fetch the data from an API. And the function goes like this, function as fetch data. Understand that a callback function is a function that can be passed as an argument to a different function. But before we do that, we are going to perform the operations here like making API calls. By this point, we are going to mimic as I just said. Now, before performing the operation, we can log this message by saying that fetching weather data. This is where we're going to make the API call, and that is simulating asynchronous operation. As we move on, we're going to use HTTP request for this. So in here, we are going to use setTimeout here, and for setTimeout, we're going to pass in a callback function and then the duration, and that is 2 seconds. This means that the operation is going to take 2 seconds before we can get the data from the API. So in here, I'm going to say that weather data fetched successfully. So we are done with the first operation, and that is making the request to the API. And after we got the response, we are going to have a function to process the data. In this case, displaying the weather data to the UI. So I'm going to have a function for that. I'm going to say function as process data, and it goes like this. We are just going to log by saying that processing the weather data to display temperature and conditions. Let me comment out these guys and let's understand what is going on over here. Like I said, for our application, we are going to perform 2 operations. One is making the API call. In this case, this function is for that. And then the function to process the data and update the UI. So now this function is going to depend on the response coming back from the data or the API. Without the data from this API or this function, we cannot process the data. This is where a callback function comes in. This means that this function is going to take in a callback function as that. You can name it whatever you want, but mostly we use callback here. So when to call this function? We are going to call this function in the setTimeout because this is where we have the response. So in here, I'm going to call the callback as callback and as a function call. So how to call this function? As fetch data. So below here, I'm going to execute or invoke the function, and that is fetch data. And note that this fetch data takes in a callback function, and that is the function that's going to take this data from the setTimeout to be processed. And we have the function here as process data. So I'm going to pass in as process data, and that is it. We are using a callback function for the operation. So if I save this one, before saving, let's understand what is going on over here. First step is that we have a function to make the API call to fetch the data. But this API call can take some time. Therefore, we need to have a function that's going to be called as soon as we get the data from this function. And this is what we call a callback function, which means that as soon as you got the data, then call me to take that data to process. So below here, we have the function, in this case, our callback function, which is going to process the data. So we are not going to execute this function, but instead, we're going to call it as soon as we got the data from the API call, in this case, fetch data. So as soon as I call this function, first step is that it is going to execute this fetch data, in this case, this one. And then we have this line of code which says that fetching weather data. So this one will be logged. And then when it gets here, it's going to delay for 2 seconds. Therefore, this one will be sent to the event loop. And then it will keep waiting. So as soon as it finishes, it's going to log this data as data fetched. And finally, we're going to call the callback here, in this case, this one. So this is going to be the last response from these operations. With this one being said, save it and let's see, and let me reload. As you can see, we have fetching data and after the duration, we got data first and then processing the weather data to display temperature and conditions. So this is how we use what is called callback function. In the next video, we are going to make rare HTTP request or API call to fetch some data and use the mechanism of callbacks to show you how it's going to work. At this point, understand the flow and the purpose and how to use callback functions. Before using callbacks in real-world examples, unless you understand how to make use of HTTP request. So let's take this opportunity to re-explain what is HTTP request. An HTTP request is a message sent by a client, usually a web browser or an application, to a server over HTTP to request data or to perform an action on the web server. HTTP stands for Hypertext Transfer Protocol. The server then processes the request and sends the response back to the user. Let's look at the components when using HTTP request. First of all, we need to have what is called the HTTP method. Let me have a comment as components of an HTTP request. HTTP stands for Hypertext Transfer Protocol, and it has the following component. One is method, and sometimes it is called HTTP verb. This one specifies the action the client wants to perform on the server resources. An example of these methods are get, and this one is used to retrieve data, and then post method for sending data to the server or to server, and then put method for update, and then delete for deleting resources. And apart from the HTTP methods, we also have what is called the URL. URL stands for Uniform Resource Locator. An example can be, for example, https://example.com. And apart from the URL, we also have what is called the headers. And this one provides additional metadata about the request. And we also have what is called the body. The body is used to send data to the server. For this example, we are going to use the HTTP method called get and then URL to make the HTTP request. So now, how can we make HTTP request? First step is that we need the URL that we want to fetch the resources from. And this one can be an API endpoint that we want to fetch. With this one being said, in the next video, we are going to make our first HTTP request. Now that we know what is an HTTP request, we are going to make our first request. And the main goal here is that we are going to make a request to a certain API and pull some resources or data into our application. At this point, let's assume that this is our application, that we want to fetch a certain data into this application. So first of all, we need the following. The first step is the URL or the API that we want to make that request. At this point, we are going to use a simple API called JSON placeholder. Now we know the API that we are going to consume. The next step is we will need what is called HTTP client. And this is a tool or a library that allows a program or client to send HTTP requests and receive HTTP responses from servers. When it comes to HTTP client, we have the following. One is fetch method. This is by default given to us by JavaScript, and we also have what is called Axios, which is a third-party HTTP client. In this video, we are going to use fetch method. This means fetch method is going to help us to make the HTTP request. So let me have a comment as making HTTP request. So first step is that bring in the HTTP client. In this case, it is fetch. This is a global method given to us by JavaScript. The next step is that we are going to pass in the endpoint or the URL that we want to fetch that data. In this case, we are going to use JSON placeholder. If you go to jsonplaceholder.typeicode.com, this is the official website. In here, they have some dummy resources that we can make use of it. And these are the resources or the URL. One is /post. This one gives us 100 posts and comments, albums, photos, to-dos, users. So in case we want to fetch these posts into our application, we may need the endpoint. And these are the routes with the HTTP method. One is get, post, put, and delete. But we are going to make use of the get method. So here, to know the endpoint or the URL, click on this. And this is the data from the API. Always, API responses are in a JSON format. It looks like an object, but this is what we call JSON data. Don't worry, as we move on into backend, we are going to build our own APIs. So this is what we are going to fetch into our application. So I'm going to copy the URL, which is this one, and back to my code, I'm going to bring either single quotes or double quotes and then paste that. So this code simply means that we are fetching this data into our application. Let me comment out these logs. Alright, next step is that we need to await the response coming back from the API. This is where .then comes in. .then is going to wait the response coming back from the API. Inside the .then, we are going to pass in what is called a callback function. You can use function keyword or arrow function. Then in the callback function here, we can perform some operations. So at this point, it is using what is called a callback function, which is this one, which means that in case we get back the response, then the callback function here is going to be executed. So what we get from the .then here is what we call the response, which is this. Then in the callback here, we are going to return the response, and to get the actual response as JSON, we're going to use .json on that. This method is used to convert to JSON format. And this one also takes some time. Therefore, we have to also wait for that. This is where .then comes in as that. Then in the .then, pass in a callback function as that. And in case something goes wrong, for example, network error, we want to access that error by using what is called .catch. All these methods were given to us by JavaScript. So in here, we're going to pass in a callback function as that. And then in the callback here for the catch, we have access to the error that will throw back from the response. Then in here, I can go ahead and log the error by saying that error fetching data. Post here, and let me inject the error as that. Then in the .then here, which is this one, we have access to the actual post. So bring in here as post, and then I'm gonna log the post here by saying that post fetched successfully. Then I'm gonna inject the post here and save it. After saving it, let's see it in the console. And there we go, post fetched successfully, and these are the 100 posts from the API. So this is how we make use of HTTP request. If I expand this one, we have the body, the title, and then the user ID. So these are dummy posts, but the concept of making the HTTP request is going to be the same. So this is how we make use of HTTP request. And we're going to use this concept a lot in Railroad project. So pay attention and ask questions what you think you find difficult to understand. Do you remember under the overview of asynchronous programming, we made mention that JavaScript rely heavily on asynchronous code. Now that we know how to make use of HTTP requests, in the next video, we are going to make use of callbacks by making two HTTP requests by waiting for the first request. When you get back the data, then we are going to call our custom callback function to work on that. With this one being said, let's continue in the next video. We are going to use the concept of callback to implement this logic. And this is the flow. We are going to use JSON placeholder for this logic. First step is that we are going to fetch user details. And we have an endpoint or API for that. Then after we get the user details, we are going to fetch the user's post. This means that this one is going to depend on the user details, which means as soon as we get the user details, we are going to pass in a callback function. As soon as we get that, we're going to take the user ID and fetch the user's post. Let's get back to the JSON placeholder and let me show you the endpoint. Below here, we have the endpoint to fetch a single user, which is this one. If I click on /users, this is going to fetch all users, but we can add the ID of the user that we want to fetch by using / either 1 or 2. If I use ID of 2, we have a single object. This means that this is a single user. So as soon as we get this data, we are going to take this ID, which is equal to 2. Then let me copy this one and then place it here. Let me get into the home page here. As soon as we get the user ID, we are going to fetch the post that belongs to that user. And this is the endpoint. Let me hit /post, and these are the list of posts. And we can find a post by user ID. To do that, bring $, and then user ID, which is equal to, for example, 1 or 2, and then hit enter. As you can see, these are the posts associated with this user. So first step is that we will need the user details to get the user ID. Then from there, we're going to fetch all the posts by user ID. In this case, we have 22 here. With this one being said, let's get back to Visual Studio Code. I'm going to copy this endpoint for the user. Back here, let me bring / that and then paste that. So there is the endpoint for fetching user details. And then this is the endpoint also for fetching a post that belongs to a user, which is this. If you look at this endpoint, this IDs is going to be dynamic. We can pass in any ID of our choice. So let's begin with a function to fetch the user details. As we did before, for this one, we are going to wrap it in a function. So I'm going to say that function fetch user data. Let me comment out these guys. All right. So for this function, we are going to make rare HTTP request as we did before by using what is called fetch and then pass in the endpoint. The endpoint here is this one. Copy and paste that. Then bring in .then here to wait for the response and then the callback function as that. And also we need to catch any errors by using .catch, which is this, and then pass in the callback function as that, and we have access to the error and we can go ahead and log the error. Once again, this is a format that you are going to use a lot, so you need to pay attention about that. In the .then here, and that is the callback function, we have access to what is called the response. And then we are going to return the response.json, and this one also is going to take some time. Therefore, we're going to use .then here and then pass in the callback function, and this is where we have the actual data or the user data. So if I log the user data here, now let's see the result. Reload. Well, I forgot to call the function, so below here as fetch user data, and let's see it. And indeed, we got the user data with the address, and then the company, and then the ID and phone number and other details. So at this point, we have the user data. All what we need is the ID of the user. So if I change the ID of 2 to something like 10, you're going to see different user, in this case Clementina. Alright, so at this point, this is where we have the data, and we will need the user ID. So here I'm going to make use of .id, and I will get the ID only. Now we are going to have a function to take this ID to fetch the user's post. So below here is going to be as function fetch user post, and it's going to be the same process as we did. I'm going to copy this one, that is a making rare HTTP request, and then paste it here. The difference is going to be the endpoint. The endpoint is this one. Copy that and then paste it here. But note that the ID here is going to be dynamic. We can use either 2, 3, or 4, and this ID value will be found in this function where we are fetching the user details. So we are going to make this one dynamic, which means that this function is going to take in the user ID. Therefore, we're going to use backtick to inject some dynamic data, and then remove this and bring in $ curly braces and pass in the user ID. So now, where are we going to use this function? We're going to use this function as a callback in this function called fetch user data. This means we're going to pass in what is called callback function here, and this one represents the function to fetch the user post. In this code, where do we have the response? In this case, over here. So this is where we're going to call our callback here. So as soon as we get the data, we're going to call the function to fetch the user post. So in here, I'm going to call the callback, and then remember that this callback represents this function below here. And note that this function takes in the ID of the user, and lucky for us, we have the ID here, so we're going to pass in here as that. We are going to log, I'm going to change this one to post, and then we're going to log the post here. So now we are going to call this function below here, and then pass in the function as a callback. So here as fetch user post as that, and save it, and let's see the result. And we got the user's post. Let me log the user details here. I'm gonna say user details fetched, then the user data, and in the user's post here, I'm gonna say that users post, and then log the post. And now let's see the result, and we got the user details. As soon as we got that, then we went ahead to fetch the user's post, which is this one. At this point, in case you are new to callbacks, this one might be confusing, but take your time and go through the code and ask questions where necessary. In the next video, we will talk more about promises, and we will repeat this format again and again when dealing with promises. So in case you're confused, don't worry, the next video we will go over again. Let's talk about promise. A promise is one of the methods that we can use to implement asynchronous code or programming. At this point, we have already talked about callbacks, which is one of the ways for implementing asynchronous code or programming. So what is a promise? The name is even descriptive, promising somebody. If you promise somebody, it has 3 states, and that is pending. Let's say that you've promised your friend to buy him or her some cake. As soon as you buy the cake and deliver to the person, then you have fulfilled your promise. And a promise can fail, which means for a promise, it has 3 states. So technically, what is a promise? A promise in JavaScript is an object that represents the eventual completion or failure of an asynchronous operation and its resulting value. It acts as a placeholder for data that is not immediately available. Promises allow us to handle asynchronous operations more clean and avoid callback hell. This means we can have deeply nested callbacks depending on the situation. This means that a promise is an improvement when using callbacks. So, how can we use promises in asynchronous environment or code? Let's say that we are fetching a data from a different server using HTTP request. For this, we are going to have three states. One is pending, fulfilled, and rejected. Let's begin with pending state. This simply means that the operation is still in progress. And this is why sometimes you see some loading spinner in some applications. This means that the operation is still in progress. And we have fulfilled. This means that the operation has been completed successfully and the resulting value is available. This is where you're going to see the red data on the page. And lastly, rejected. This means the operation failed and the reason or the error is available. Based on this one, let's get back to Visual Studio Code to put them into practice, and this is where we left. Like I said, we have already used a promise when we're talking about callbacks, but let's try to reiterate. I'm going to comment out these guys, even the function call only, and nothing is being logged. First step is that we need to create the promise. And after creating, we need to use or consume the promise. So how can we create a promise? We are going to use what is called new and then uppercase P as promise. Then in this function, it is going to take in a callback function as that. You can use function keyword or arrow function. Then in the callback function, we are going to pass in two arguments. The first one is called resolve, then comma reject. And these two arguments are functions. So what are they? We use resolve when the task succeeds and reject when the operation fails. Let's say that we are making a request to JSON placeholder to fetch some post. For this situation, we can get back the response. In this case, we're going to use the resolve. But in case something goes wrong, then we are going to use the reject. So the resolve and reject are functions. You can use any name of your choice. The first one always represents the resolve and the second one represents the reject. Then after creating, we are going to consume the promise. So I'm going to assign to a variable as const my promise, which is equal to this. Now, how can we consume the promise? Always bring the variable name of your promise instance as my promise. You can use any variable name of your choice. Then on the promise instance, we're going to use a method called .then. We use .then to handle the fulfilled state. And then .catch method. This one is also used to handle the rejected state. And lastly, we have what is called finally. And this function is going to execute regardless of the promise's outcome. And each of these ones, we are going to pass in a callback function. So in here, I'm going to use arrow function. Likewise, in the catch here, I'm going to use arrow function. And then the finally also arrow function as callbacks. In the .then, we have the actual data. And then in the .catch, we have the error. Let's finish up with the creation of the promise. So in the function body here, we are going to perform some asynchronous task. For example, making HTTP request. At this point, we are going to mimic or simulate some async operations. So I'm going to say that here perform, and I'm going to say that let success equal to true. This means that the operation is being fulfilled. Then we are going to use these methods to resolve the promise. So here, if success, which means everything went on well, then we are going to use the resolve method. So bring in here as resolve, and then as a function call, we're going to provide, for example, operation successful. So this means that the promise is being fulfilled. Else, this means that we have an error, therefore we are going to call the reject by saying reject, and I'm going to say that operation failed. Good. So we are done with the promise creation. Now it is time for us to consume the promise, and we have already have the implementation. So in the .then here, this is where we have the success state. This means that the value in the success will be available in the .then, and then the value in the reject will be available in the .catch. So in here, if I log the data here, and then in the .catch, I'm going to log the error. And in the finally here, it's going to call regardless of the operation. So I'm going to say that operation called. And normally we ignore the finally, but let's bring it, or let me remove it for simplicity. Alright, so with this one, if I save it, which of these logs will you see? Will you see the operation successful or operation failed? Know that we have success here, which is true. Therefore, this operation will be called, and we have access to this value in the .then here. And before saving, I have removed the new here, so bring new here. Now save it and let's see, and we got operation successful. If I change this one to false, which of these logs will you see? It's going to be the rejected one, and we got operation failed. So this is how we use promises in asynchronous environment. Now with this one being said, in the next video, we are going to make a request to JSON placeholder to fetch some post. And we have already done that when we are talking about callbacks. As you can see here, we are using .then and then .then here. Alright, in the next video, we will reiterate. Let's continue in the next video. We are going to use promise to make some HTTP requests. And once again, we have already used this one before, but let's try to reiterate. We are going to use JSON placeholder. So below here, we are going to fetch, let me check, let's fetch some photos here or to-dos. Let's use albums, this one. Alright, so we're going to fetch this one using promise. I'm going to copy the URL, and then back here, let me comment out this to avoid so many console logs, and I'm going to say promise examples or example. So first step is that we need to create the promise, and then secondly, we need to consume the promise. Now we are going to use fetch HTTP client, and by default fetch method is a promise base, meaning that it has been created already. All what we need to do is to consume it or to use it. So instead of us creating a promise when making real-world requests, we're not going to do that, but instead we are going to consume the promise. So in here, bring in the fetch HTTP client, and then it takes in the URL. So this is a promise base. If I assign, let me assign this one to, let me say fetch data promise, which is equal to this. If I log this variable in the console, let me see, as you can see here, we have a promise base, and that is fulfilled equal to this one. This means that the HTTP client called fetch is a promise base. So let me comment out these ones to avoid so many logs. Alright, so now we know that the fetch is a promise base. Therefore, we are going to consume the promise. Is that not it? Yes. So now I'm going to take this fetch data promise here, and then we are going to consume it. Then in here, bring in the fetch data promise, and we're going to use .then. Remember that we have access to the actual value from the response in the .then here. So I'm going to pass in a callback function as that. And then catch, in case we have an error, also a callback function. So in the .then here, we have what is called response. So if I log the response here, let's look at the data. If I do that, and as you can see here, let me remove this one from here, and let me reload, and we have response. And these are the properties from the HTTP request, which can be found in the .then here. Now, we don't have the actual response. If you look at the body, we have what is called readable stream. This means that the actual data is not available yet. This means we have to resolve the promise once again to get the actual data. So in here, we are going to return, and then response. On that, we have a method called .json. And this one is also a promise base. Let me prove to you. I'm going to assign to a variable as my response equal to that. If I log my response, you're going to see promise. Anytime you see something like this as a result, it means that you have to consume the promise. It is still pending. So in this case, to resolve the promise, we are going to use .then on it. So remove this one, and now let's bring return here. And then change it by using .then. You can have unlimited .then depending on the state of your response. So this is where we have the actual data, and let me log it as data here, and now let's see it in the console, and we have the response. But if I tamper with the URL to something like this, let's see, and now the catch block has been called, where I forgot to log the error here, and now let's see the error. It says that type error failed to fetch. This means that this block of code is being called. Nice. So guys, this is how you use promise. Let me undo and use the right endpoint. Alright, it worked. So guys, this is how you use promise. But we can refactor this code. Instead of assigning the response to a variable, we can chain it. So I'm going to copy this one and comment out for future referencing. So in here, remove this one, and then remove this, and use .then after the URL as that, and it will work. Let's talk about async await. Async await is one of the methods that we can use to implement asynchronous programming or code. At this point, we have already talked about callbacks and promises. This means that async await is going to be an improvement when using promises. As the name implies, awaiting. This means wait for me before doing something else. So technically, what is async await? This is a feature in JavaScript that simplifies handling asynchronous operations, making your code easier to read and maintain. It is built on top of promises, allowing us to write asynchronous code in a way that behaves like synchronous code. This means that it is going to simplify the way we use promises. So as the name implies, wait for the task to complete, and then we handle the promise in order. With this one being said, let's get back to Visual Studio Code to put them into practice. We are going to rewrite this one to use async await. So I'm going to comment out this one. Let me have a comment as async await. When using async await, the first step is that you need to have a function. This means all your logics must be in a function. We are going to make a request to fetch all the albums using async await. So we're going to have a function as fetch albums. And for async await, always mark your function as an async, which means asynchronous. Then in the function, bring try and then catch. Let's expand it as that. Likewise, this one. So what is the try here? This is where we are going to have the success of the response. And then in the catch, we're going to have the error in case we're going to have one. So the try is similar to resolve when using promise, and the catch represents the rejected state. So this we're going to have the success, and then here we have the failure. So in the catch, we have access to the error here, and let's log the error as that. So let's make the actual request here. I'm going to assign to a variable as albums equal to fetch, and then the URL. I'm going to use the same endpoint and then place it here. And note about this. Any response that's going to return a promise, mark that one as an await. So this means that if I log the albums, which is this, let me call the function as fetch albums, and now as you can see here, you're going to see promise. This means that I have to bring await in front of this one. This means that wait for me, that is awaiting. So if I do that and then if I save it, I have the response, but on the body we don't have the actual data. This means unless we await this one also to get the actual data. So we are done with the first step. Second step is that I'm going to assign, let me call this one as albums response. Then in here we have the actual albums, which is equal to albums.json. And once again, if you log, there's a trick to show you when to use await. And then albums here, we still see promise here, and we have fulfilled, and we have the data. This means we have to await this one also by bringing await in front of it, and now we have the response. As you can see with the async await, we don't need the .then. We have a simplified syntax as this. This is how we use async await, and you're going to see this kind of syntax in many code bases.